Hi, this is Calandra. In this video, we'll talk about what's meant by even and odd functions. A function that is symmetric around the y-axis is said to be even. To determine if a function is even, we must verify that when you substitute in a negative x value into your function, you're going to get the same answer as if you substituted in the positive x value. So here's some illustrations of even functions. So by sight, we can see that a function is symmetric around the y-axis. If you fold your graph in half along the y-axis, the two sides will meet up perfectly. Okay, another way that you can look at this is in terms of our function notation, is if we have an x value, and let's say we have the negative x value on the other side. When I look at the corresponding point on the graph, let me be more precise here. Notice that they have the same function value. So this function value, based on my negative x, would be f of negative x, but it would be exactly the same thing as the function value that goes with x. So that kind of illustrates where we get this rule from. Okay, the similar examination can be done of this absolute value function. By sight, I see that it's even because if I fold the graph along my y-axis, the two sides will meet up perfectly. A function that is symmetric about the origin is said to be odd. To determine if a function is odd, we must verify that when you substitute in the opposite of x, you'll get the same answer as if you take the opposite sign of the function value when you just substitute in your x. So let's first talk about what this means visually. Something that's symmetric about the origin means that you flip it around the y-axis and then flip it around the x-axis, and you should have a mirror image. So we see that it looks like a mirror around the origin. Again, for the second graph, visualize, just looking at the first quadrant, flipping it around your y-axis, so we would have something that looks like that, then flipping that graph around the x-axis, and that gives us the other portion of the graph. So that's how you can determine if you have something that is symmetric around the origin visually. Now in terms of function notation, okay, if I have my x value here, and why don't we just use 1 for an example. I'm just going to go ahead and call it x. So if that's my x, and I have my corresponding y value, which is f of x. Well, if I take the opposite sign of this f of x, so that's going to put me down here. So that's negative f of x. That value is going to be the same as the function value if I substitute negative x into the equation. So if you have a hard time grasping this concept visually, you're just going to be able to work this out using your equations. As long as you remember this rule, we'll be able to come up with our answer. Okay, so let's look at a few examples of this. Determine if the following functions are even, odd, or neither. So for our first one, I see that this looks like it's an even function. If I fold it along the y-axis, it looks like the two sides will meet up. But to verify it, we need to check that f of x is equal to f of negative x. Well, we already know what f of x is equal to, so I just need to calculate f of negative x. So when I substitute negative x in everywhere I see an x, we have negative x, that quantity to the fourth, minus 4 times the quantity, negative x squared, plus 3. Well, negative x to the fourth will end up being a positive x to the fourth. Negative x squared will be a positive x squared. So notice that we end up with the same quantity. So therefore, since these two things are equal, this is an even function. So even if we didn't have the graph, we could have worked through this and determined that it was even. Okay, going on to our next graph. Okay, well, we see that this will not be even. The only option would be for it to be odd. But I can see from the graph it's not even odd because it is not symmetric around the origin. It's to the right of the origin. So let's go ahead and check. Let's say that you weren't sure and you want to check to see if it's odd. That means we're looking to see if the opposite of f of x will equal f of negative x. Okay, so let's start with finding negative f of x. That just means I'm multiplying my entire function by a negative. So we end up with negative x squared over x minus 1. Okay, well, I need to see if this is equal to f of negative x. So I'm plugging negative x in for all of my x's in my original equation. So negative x quantity squared divided by negative x minus 1. Well, negative x times negative x is positive x squared. In the denominator, we have negative x minus 1. So notice that these two things are different. So we know that it's not odd. We also know it's not even because f of x, the original function, does not equal f of negative x. So it's not even because f of x does not equal f of negative x. Therefore, this function is neither even nor odd.